5.3 and 5.4. When you look at number 5 and 5.3, we're going to use this formula because they told us that it was compounding continuously. They gave us a rate of 5.25%. Well, that's equal to 5.25%. And so converting that into a decimal, that would give us 0.0525. Then they told us that it compounded for 5 years. So we do 1,000 times e raised to this number. We get approximately $1,300.18. Similarly, they said, what principal would we need if we end up with $100,000 at a rate of 3.4%? So that'd be 0.034 for 18 time steps. Well, that means that since we have p times this number is equal to this number, we divide both sides by e to the 0.0434 times 18, and we get that p is approximately equal to this. 9, in this case, now we're solving for the rate. So we got $1,000, 20 years, and we want to end up with $4,055. So if we notice right now, it is not in exponential form, but if we divide by 1,000, since it has 3 zeros, dividing by 1,000 is the same as moving the decimal 3 places to the left. So now I have e to the this is equal to a constant. So this is in exponential form. We can convert it to log form. So that's really the natural log of this number is equal to 20r. In other words, r is equal to natural log of this number divided by 20. In other words, approximately 0.07, which is approximately 7%. If we look at 17, they want us to find all the zeros of this function, all the solutions of this. Well, when you look at it, I need you to see two terms, two things that were added together. So one term plus another term. So what's constant to those terms, it looks like I can pull out an e to the 4x and an x squared out of both terms. And then I ask myself, this times what gives me the first term? I guess it would be 4x. And this times what gives me the second term? I guess it would just be 3. So now I need you to view it as 3 things that got multiplied together. Now there are 3 factors. This times this times this equals 0. So either the first one was 0, the second one was 0, or the third factor was 0. So the first factor equals 0 means there is no solution, because we know that y is equal to e to the 4x is an exponential growth type of a situation. Horizontal asymptote at y equals 0. It turns out it never quite gets to that asymptote in this case, so there's no solution. This is x equals 0, and this is x is equal to negative 3/4. So those are only 2 answers. In this situation, number 24, we set 1985 as our starting value, so that's time equals 0. So it turns out that at time equals 0, we have 766 million people. So let's talk about the population of India. So you let the reader know what the variables are. P is population in millions. T is time in years since 1985, which was a great year, by the way. So here, we're going to use population is initial population e to the RT. So there's our initial population. And it said it grew at a rate of 1.82%, so that's why that's R. And then it said, what's the population going to be in 2015? Well, 2015 minus 1985 means it's 30 years later. So putting this in the calculator, we get about 1322 million, which is about 1.322 billion people. Okay. Then we now go on to 5.4. Making sure that's cool. So in 5.4, it says solve this equation for t. Well, first I need to get it into exponential form so I can then convert it to log form. Well, to get it into exponential form, I divide by 2, and now I have a coefficient of 1 in front of my base, so it is an exponential form. So this would be log base A of this is equal to the exponent, because a log is just an exponent. So that's why it's log base a of 5/2 is equal to t over 3. Multiply both sides by 3 and I get this. Here, to solve for this exponent, again, I first must get it into exponential form before I can convert to log form. So if you subtract h, we get this. Then if you divide by negative c, a c goes in the bottom, and that negative is going to switch the order on top. So now I have a to the t, and there's an understood coefficient of 1 in front. So that means that this is now in exponential form. And I can now convert it into log form. To convert it into log form, it's going to be log base a of this stuff is equal to my exponent, because a log is just an exponent. And that's what we get. Looking at 15, these are knowing your log properties. So all of these would be without the calculator if I gave it to you. So this would be log base 5 of 1. That's got to be 0 because 5 to the 0 is 1. Log base 3 of 3 is 1 because 3 to the 1 is 3. Log base 4 of nothing gets you negative 2. There's no solution. There's no way to multiply 4 by itself and eventually get negative 2. 7 to the what gives you 7 squared? Well, that would be 2. 3 raised to the log base 3 of 8 is 8 because that's what this does. Log base 3 of 8 is just the exponent that when you take 3 and raise it to this exponent, you get 8. So that's why it is what it is. Visually, you can maybe remember it by that exponent and log kind of cancel each other out. Log base 5 of what is 125? Well, 5 to the third is 125. Here, this is in log form. I converted it to exponential form. Then 1 over 16 is 16 to the negative 1. 16 is 4 squared. When you raise to a power and raise again, you multiply exponents. So now it should be clear that x is equal to negative 2. And that's true because 4 to the x is 1 to 1. So if you have equal outputs, we must have equal inputs. Okay. If we look at 17, 10 to the log base, well, there's an understood 10 here. Log base 10 of 3. Again, these cancel out in some sense, and you get 3. Log base, there's an understood 10 if they don't say it. So log base 10 of 10 to the 5th is 5 because 10 to the 5th is 10 to the 5th. Log base 10 of 100, that would be 10 to the x is equal to 100. So x must have been 2. Log base 10 of 0.0001 is saying 10 to what power gets you this? Well, this is just 10 to the 4th, right? Why? Because when you multiply it by 1, 2, 3, 4, you get 1. Or another way to think about it is you start with 1 and go 1, 2, 3, 4 to the left. That's why it's 10 to the negative 4th. So you get this because 10 to the x is 1 to 1. So equal outputs means equal inputs. Here, if you have 10 to the 1 plus log of 3, that's the same as 10 to the 1 times 10 to the log of 3. But 10 to the log of 3, that's log base 10 of 3. So that's why this just ends up being 3. And so you get 30. Here, if we have log base 4 of something is equal to log base 4 of something else, then those inputs must have been equal because log base 4 of x is 1 to 1. So equal outputs means equal inputs. Solve and you get x is negative 1. Here, if we have e raised to the 2 natural log of x, notice you can bring this up by properties of exponents. We get e raised to the natural log of x. But e to the natural log of anything, these cancel each other out in a sense. You get x squared is equal to 9, so when you solve, you get plus or minus 3. But remember, you have to check and see if those work in the original. Only positive 3 works, because if you try and plug it back in here, you cannot plug a negative into natural log. So there's only one answer. Here, they want you to rewrite this thing in terms of e to the stuff. Well, notice what happens. You use the property that we just looked at a second ago. If you have e raised to the natural log of something, these will cancel out and just give you this. So you can actually go the other way. And if you have any number, you can rewrite it as e to the natural log of that number, and it's equivalent. And all of this is equivalent to all of this, because these cancel out. Why would I want to do it that way? Because then I can pull this x out front, and I really have e to the x times a number. So it's now written in that form that we like, and it turns out that that is approximately negative 0.0305. So this thing is approximately 20 e to the negative 0.0305x. So another way to think about this is it's really exponential decay by a rate of about 3.5%. 0.05%, excuse me. Okay, pretty cool. The way that we saw this is we see that it's this decay of 3% every time step, but in terms of exponential, it turns out to be that. All right, when we see this, they want us to solve for t. Notice it's not in exponential form yet because there's a 20 in front of the base. When you divide now, it is in exponential form. Why is that great? Because then we can convert it into log form. And the way that you can convert it into a log form is by, since it's base e, it's going to be the log of this is equal to this. And that's what we have here. Then we're trying to solve for t. Multiply both sides by L, you get this. Divide by negative t, and you get this. And that should be it. That's it. As always, come in with questions. Office hours are every black day at 7:45, and then after school on Mondays and Wednesdays. Have a good one.